This conference will now be recorded.
Is everyone following this session? Please let me know so that only I can continue the session. If you are not following, what is the purpose?
Yes, madam, we are following.
Okay. So here, first we have to give the power supply to the LCD board. So for giving up the power supply to the LCD board, what is the purpose of giving power supply to the LCD board means? In the 16:2 LCD board, we have to give two power supplies, one for the board and other for the rows and columns. Okay, first we have to give the power supply to the board, LCD board. For giving up the power supply here, as I told you before that we have to give two power supplies and five grounds. So that in Arduino board we have only single power supply and only three ground pins. So in that cases we have to common the particular power pins or the ground pins. So select the 5 volts pin, make it as a common, take the ground pin and place it here. So one is referred as a ground. I am changing its color into black for the ground. Okay, and power supply pin will be changed into red color. That is the indication that the this is the 5 volts pin and this is ground pin. Next, here you can see here this is the LED plus pin, LED anode. LED anode means giving power supply to this LCD board. So connect this LED anode pin to breadboard, positive 5 volts pin and next LED cathode to ground. Okay. So when you start the simulation, you can see here something blast has occurred here, right? Because it only support it's then capability it should upper its capability is not the 5 volts sub 5 volts voltage. Okay, so it needs some low voltage. For the purpose we have to connect here through resistor. We have to connect it to through resistor. We have to connect it to ground. Okay, take a resistor. So you can see here when you simulate this board, you will not get any blasting symbol on the LCD board. Okay. After completion of giving power supply to the board, next we have to give the power supply to the columns, rows and columns. So connect first pin. First pin is the ground pin. This means VDD pin. VDD pin should be connected to ground. VDD is connected to ground. And next VCC should be connected to 5 volts pin. Likely we have to connect it to 5 volts pin. And next third pin. Third pin VE should be connected to ground. So here you can see the change. When you simulate this board, you can see the rows and columns will be presented on your display board. Is everyone clear still these connections? Is everyone clear with these connections? Giving
Yes,
power
ma'am.
supply to the board and the rows and columns. Okay, if everyone is clear, I will be moving to do some other connections. Okay. Next one is register selection pin. So for every controller for every data transferring we have to select the register selection pin. So that all so so that whatever the data we are sending to the particular display, and whatever the data we are getting from the controller. Whatever data we are sending and receiving, so all those data will be stored in the register selection pin. So we have to select the register selection pin. Connect this register selection pin to digital pin. Okay. And next, the read or write pin should be connected to the ground pin. This is read or write pin. Why we are connecting this read or write pin to ground pin means, if we are sending the data to the LCD display, then we have to make the read or write pin as low. If we want to send the data through the command lines, so then we have to make the read or write pin as a high pin. So connect this read or write pin to ground pin. Okay. Next, for every data transferring, enable pin should be in the active high state. So connect this enable pin to digital pin, any of the digital pin. Okay. So here I am connecting this enable pin to any of the digital pin. Next pins, how many pins we have? We have 8 pins. These 8 pins are the data pins. Okay, these 8 pins are the data pins, but based on our bit code, based on which bit coding you are writing for the LCD display, based on that we have to connect these 8 data pins. Here I am writing the for display I am writing 4-bit coding. So if I am writing 4-bit coding to the display, so we have to connect to the only 4 digital pins. But in this 4-bit coding for the LCD display, first 4 data pins doesn't exist. So we have to connect the next 4 data pins. Okay. So connect to D4, D5, D6, D7. So D4 pin is connected to 5, D6 is connected to 4, D5 is connected to 4, and I'm here connecting D6 to 3, and D7 to 2. You can connect it to any of the digital pins. Just here for reference, I am connecting any of the pins. We have to connect the data pins D4, D5, D6, D7 to digital pins in Arduino board. Okay, everyone is completed this connection. Please let me know. All of you completed these connections. Please let me know if everyone has completed these connections or not. All of you understood or not, so that I can move to the programming part. This those four pins doesn't exist in the 4-bit coding. If you are writing in the 8-bit coding program for the LCD display, then then those D0 to D3 pins also will be existed. Okay. In 4-bit coding, first four data pins are not existed. Okay, next I'm going to the coding. So take a library file, hash include liquid crystal dot h. So next assign a variable name for the library file so that we can call throughout the program the that particular variable name of. So next we have to indicate all the pins for which we have connected the digital pins. So first we have to indicate register selection pin. Here I am connecting my register selection pin to RS pin to 13th pin. Next enable pin. Enable pin is connected to 12th pin. And next data pins. Data pins are connected to its remaining 4 digital pins. Okay. Here I am writing in the comment line. RS enable D4, D5, D6, D7. Okay. Next void setup, loop open, LCD dot begin 16 by 2. It is also one of the display. Okay. So for we have to indicate how many columns and how many rows are present in the LCD display. For the display which we have taken here, for this we have 16 columns and 2 rows. So here I am indicating that we have 16 columns, 2 rows. For indicating purpose, we are using the syntax that is else begin syntax dot begin. Before that, we have used the LCD. LCD is the variable name of the header file. Okay. For liquid crystal display, we have assigned LCD is the variable name. So we can assign any of the variable name. Okay. Next here I am printing the data in the LCD display. So LCD dot print hello APSSTC. Okay. So next I am opening the main loop, but I am not writing any program in the main loop. If I have written this printing statement in the main loop condition, so continuously data will be printed in the LCD display. If you are writing in the setup function, so only single time we will get the display. So I am starting here simulation. So you can see the output. So have written that hello APSSGC should be printed in the LCD display. Okay, that is what the output I got in the LCD display. Everyone has got it. Everyone has got the output. Please let me know so that I can move forward. In this LCD display, we have different categories. So we can use different formations and we can make the display scroll, and we can clear the display, and we can make the display has a blinking. So everyone got the output. Okay. For making up the data scrolling, we have to use the syntax LCD dot scroll display. So if we want to scroll the data from left to right or right to left, based on that we have to give the indication. So here I'm giving the right side. So in this scrolling also I need some delay. I given here half second of delay. సో మీరు షాపింగ్ మాల్స్ లో చూసే ఉంటారు, డిస్ప్లే మీద మనకి డేటా అనేది స్క్రోల్ అవుతూ ఉంటుంది కొంత టైం డిలేతో. కొన్ని కొన్ని డేటా వచ్చేసరికి ఫాస్ట్‌గా స్క్రోల్ అవుతుంది. బస్ స్టాండ్స్‌లో కానీ, రైల్వే స్టేషన్స్‌లో కానీ. కొన్ని కొన్ని సమ్ డేటా వచ్చేసరికి స్లోగా స్లోగా స్క్రోల్ అవుతుంది. బేస్డ్ ఆన్ ఇట్స్ డిలే ఫంక్షన్ వాట్ వి హావ్ గివెన్ ఇన్ ద ప్రోగ్రామింగ్. We have missed the semicolon. Okay, you can see here half second. For every half second data has been scrolling. Okay, if we want to blink the data, we want to blink the data. So blinking should be done continuously. So that's why I'm removing this data from setup function, and next I'm placing it in the loop function. Okay, so for displaying LCD dot display after some time delay of half second, data will be disappeared. LCD dot no display. Okay, సో మళ్ళీ మనకి ఒకసారి డిస్ప్లే అయ్యి డేటా అనేది మళ్ళీ కాసేపు అది డిసపియర్ అయ్యి మళ్ళీ మనకి డిస్ప్లే అవ్వాలి. సో మళ్ళీ హాఫ్ సెకండ్ టైం డిలే తర్వాత మళ్ళీ మనకి డేటా అనేది డిస్ప్లే అవుతుంది. సో ఇక్కడ మీరు చూడొచ్చు అవుట్పుట్లో. సో మనకి హలో ఏపీఎస్ఎస్డిసి, హలో ఏపీఎస్ఎస్డిసి ఏమవుతుంది, ప్రింట్ అయిన డేటా అనేది డిస్ప్లే అవుతుంది. సో ఇక్కడ నేను లూప్లో రాశాను కాబట్టి మనకి ఇక్కడ కంటిన్యూస్గా జరుగుతుంది. సో ఈ డేటా అనేది లూప్లో కాకుండా సెటప్ ఫంక్షన్లోనే ఉంచేసేయండి. సో సేమ్ డేటా మనకి కంటిన్యూస్గా డిస్ప్లే అవుతూ ఉంటుంది. సో ప్రీవియస్గా వచ్చేసరికి లూప్లో మనం ప్రింటింగ్ స్టేట్మెంట్ని లూప్లో రాసుకుంటే కంటిన్యూస్గా ప్రింట్ అవుతూ డిస్ప్లే అవుతుంది. సో ఇప్పుడు మనకి ఓన్లీ సింగిల్ డేటానే సింగిల్ స్టేట్మెంట్ ప్రింట్ అవుతుంది. అదే స్టేట్మెంట్ బ్లింకింగ్ అవుతుంది. ఓకే, in this by using this syntaxes we are making the blinking of data in the LCD display. Okay, clear for you all? Is everyone clear with this? So I can stop the today's session. On tomorrow's session you will be having on the keypad interfacing and temperature sensor. Please let me know, is everyone understood with this LCD display project? Can I stop the session? అలా చేయలేము ఈ స్క్రీన్లో, టాప్ టు బాటమ్. ఓన్లీ రైట్ అండ్ లెఫ్ట్ వరకే మనం స్క్రోలింగ్ చేసుకోగలుగుతాం. Okay, anyone have any doubts? Anyone have any doubts? You can ask the questions if you have any doubts. Okay, thank you. So that I am closing the session for today. Tomorrow we will be going with the keypad interfacing, and keypad will be interfaced with the LCD board. Okay, thank you for you all. Thank you for you all for attending the session. Can all view the session? Okay, everyone can leave the session. Thank you for attending. I didn't get your question, Manoj Kumar. What you are asking? So digital pins are interfaced in the LCD variable. There is no need of calling digital pins every time. Just we are assigning all the digital pins to the header file only. Do you have any doubts? Okay, okay, guys. Thank you for attending. You can all leave the session. I'm closing the session for today.